Hello everyone. Today we're going to be doing the Physics Week 11 AMS quiz. And yeah, let's start. Question 1. Which of the following best describes matter in a solid state? Select all that apply. So for this, you just need to memorize that particles in a solid are closely packed, they form ordered arrays, and that they vibrate around fixed positions, unlike liquids and gases which move around mostly freely. So that's it for question 1. Question 2. Which statements are true about the behavior of particles of matter during vaporization? Now, vaporization means liquid to gas. Okay? So, during vaporization, matter absorbs heat. This is correct since to change from a liquid to a gas, you need to add heat. So, this option is correct. Option 2. During vaporization, the distance between particles of a liquid increase. Now, liquids are more closely packed together than gases. So, for a liquid to become a gas, the distance between its particles needs to increase. So, this option is correct. That's it. Question 3. Option 3, sorry. During vaporization, particles gain kinetic energy. Now, this is wrong since during vaporization, particles gain potential energy while kinetic energy stays the same. So, this option is wrong. While this option that says that during vaporization they gain potential energy, this is correct. During vaporization, particles increase their speed. This is wrong since we said they keep the same kinetic energy, which means that they don't increase or decrease their speed. So that's it. Question 3. Which of the following facts supports the idea that particles of a gas move more freely than particles of a liquid? This you just need to memorize that diffusion and Brownian motion are examples and facts that show that gases move faster than liquids. That's what you need to memorize. Question 4. How does increasing the absolute temperature of a gas affect its average kinetic energy? For this, you need to understand that kinetic energy and absolute temperature are proportional, which means that if temperature increases, kinetic energy will increase. If temperature decreases, kinetic energy will decrease. So here they said increase absolute temperature. So average kinetic energy is gonna increase. That's it for this question. Okay. This question is just all memorization. No definite shape and volume. You need to know that that is a gas. Strongest interaction between molecules, so basically strongest bond, which is a solid. Vibrate about fixed positions. You also need to memorize that that's a solid. Take the shape of the container. You need to know that it is liquids and gases. So no matter what container you put them in, they will always take the shape of their container. Question 6. The diagram below shows the path of smoke particles in air when observed under a microscope. Choose the correct answer that completes the sentence. The smoke particles undergo small random movements due to what? You need to memorize that they undergo random movements due to the collision with fast moving air molecules, which is what we call Brownian motion. So you also need to memorize and understand this. Okay, so question 7. The tiniest particle of matter that retains its chemical identity. You need to memorize that this is the definition of an atom. So yeah, random kinetic energy of a body's particle determine the amount of its heat energy. This is also just memorization. That kinetic energy is related to the amount of heat. So that's question 8. Question 9. 3 moles of a gas are stored in a 4-liter vessel. 4-liter vessel at 8.5 times 10 to the 5 pascals. Use R is equal to 8.31. The absolute temperature is, so we need to find absolute temperature. So we're gonna write the law, which is PV is equal to nRT. We're gonna write our givens. So pressure is 8.5 times 10 to the 5 times volume. Now, in this type of question, we need to make liters into cubic meters. So to do that, from liter to cubic meter, you need to multiply by 10 to the negative 3. to make it cubic meter. So here we have 4. To make it into cubic meter, we multiply it by 4 times 10 to the negative 3. So 4 times 10 to the negative 3 is equal to N, which is the number of moles. They already told us is 3, times R, which they told us is 8.31, times T, which we're trying to find. We take these to the other side on the calculator, and if we do it, we are gonna get 136, which is our answer. And yeah, that's it. Next question. A fixed amount of gas is kept at a constant pressure. The initial temperature of the gas is 300 Kelvin and its volume is 2 liters. If the volume of gas decreases to 1.2 liters, its temperature becomes what? Okay, so here we're gonna use P1 V1 over N1 T1 is equal to P2 V2 over N2 over N2 T2. Okay, so they told us that it's a fixed amount of gas, which means that it's the same number of moles. So we're gonna cancel these moles out. At a constant pressure, so we're gonna cancel out pressure. So we end up with V1 over T1 is equal to V2 over T2. We have V1, which is right here, 2 over T1, which is 300, is equal to V2 over T2. They told us that V2 is 1.2 over T2, which we're trying to find. We cross multiply, we will get 180. And that's it for this question. Okay, so that's it for this question. Next question now. The cross-sectional area of a shoe's heel is 150 centimeters squared. The weight of the person wearing these shoes is 600 newtons. The pressure. Okay, so we need to find pressure. So here we're going to use the rule, which is pressure is equal to force over surface area. So we have force, which is 600. So P is equal to 600 over. They told us that the one shoe area of a shoe's heel is 150. And we have 2 shoes since he's standing on the ground. So it's going to be 300. Now, from centimeter squared, we need to make it meter squared. So you need to memorize that from centimeter squared to meter squared, it's 10 to the negative 4. So we're going to have 300 times 10 to the negative 4, which if we do on the calculator, 300 times 10 to the negative 4, we're going to get 20,000, 20,000, which is equal to 2 times 10 to the power of 4, which is our answer. And yeah, that's it. Okay, question 12. A diver of mass 70 kilograms swims in the salt water of density 1020 kilograms per meter cubed. The diver is 5 meters below the surface of the water. Use G is equal to 10. Okay, so here we're going to use a rule, which is pressure is equal to density times gravity times height. So pressure is equal to density, which they told us is 1020, times gravity, which is 10, times height, which is height under the water, which is 5. So if we do that on the calculator, we will get 51,000. And since here they said kilopascal, so we divide by 1,000 since kilo is 1,000. So we get 51, which is the correct answer. Question 13. A small object is immersed into a liquid of density 1,000 kg per meter cubed. The object is 2 meters below the surface, USG is equal to 10, and the atmospheric pressure is equal to 100. So we're going to do the same thing we did we're gonna do pressure is equal to density times gravity times height. Now, we have density, so pressure is equal to 1,000 times height times gravity, so times 10 times 2, which is equal to times 10 times 2 equal to 20,000. Now, since here they want it in kilopascal, we're gonna divide by 1,000. So we're gonna have the pressure is equal to 20 kilopascal. Now here since they gave us atmospheric pressure, and they didn't say that, they told us that it's on a surface of a liquid, which means that the liquid, so we have the liquid, the object is here. Above the liquid, there is also the air. So they told us that atmospheric pressure is 100. So the pressure on the object is going to be pressure of the liquid plus pressure of the air. So to our 20 kilopascal, we're going to add 100 kilopascal, which is the atmospheric pressure. So it's going to be 100 plus 120, which is equal to 120 kilopascal, which is our answer. So that's it for this question, question 14. Okay, so here, a hydraulic press, basically, the force exerted on this, so force over surface area is going to be equal to force over surface area. That's it, we write the ratio. So 20 newtons exerted on 4 centimeters squared is equal to x newtons over 50 centimeters squared. So we cross multiply. 20 divided by 4, we'll get 250, which is our answer. And that's it, question 15. A truck has its mass uniformly supported over 10 tires on 3 axles. Each tire exerts a pressure of 200 kilopascals on the ground and is in contact with the ground over an area of 400 centimeters squared. Take G is equal to 10 meters per second squared. Okay, so we're going to use our rule, which is pressure is equal to force over surface area. Okay, so in this question, they gave us pressure, which is 200 kilopascal, which is 200,000. This is for one tire, each tire. So 200,000 is equal to the force over the surface area, which is 400. And as we said, since it's centimeter squared to meter squared, we need to multiply by 10 to the negative 4. So it's 400 times 10 to the negative 4. So if we do this on the calculator, 200,000 is equal to x over 400 times 10 to the negative 4. And we solve for x. We'll get that x is equal to 8,000. So our force per tire is equal to 8,000. Now, since we know that the force in this case is going to be the weight of the truck, since it is what is being exerted on the ground. So force is equal to mass times gravity. So we know that force is 8,000 is equal to mass times gravity, which they told us is 10. So we get mass is equal to 800. Now this is per one tire. We solved for one tire. Since they told us that it is supported over 10 tires, we multiply this by 10. So we'll get mass of all 10 tires is equal to 8,000 kilograms. And from kilograms to tons, you need to remember that we divide by 1,000. So 8,000 divided by 1,000, mass is equal to 8 tons. And yeah, that's it for this question. Next question now. pressure is a scalar quantity equal to force per unit area. You need to memorize that. It's a scalar quantity. And basically this means this is what we've been doing, force per area. So if you memorize the rule, you'll be able to know this, and you need to know that it's a scalar quantity. That's it. Which means that it has no specific direction. Okay, question 17. Which statements describing atmospheric pressure are true? This also you need to memorize. Atmospheric pressure is always constant. This is wrong, since weather affects atmospheric pressure. Difference in pressure causes winds to blow and rain to flow. This you need to memorize. It's also correct. Affected by weather conditions. And temperature do not affect, wrong, since temperature affects pressure. Temperature causes air masses to expand or contract, affecting the pressure. This is also correct. So this question you need to memorize. Question 18. Okay. Question 18. Consider the closed-end manometer below. Take G is equal to 10 meter per second squared and density of mercury to be 1.36 times 10 to the 4 kilogram per meter cubed. Fill in the blank. If heights H1 and H2 are 12 and 60 centimeters respectively, then the pressure of the gas in the bulb to one decimal place is equal to how many kilopascals? Okay, so for this, we're gonna use our rule, which is pressure is equal to density times gravity times height, right? So we're trying to find pressure. So we have density. They already told us it's 1.36. So 1.36 times 10 to the 4 times gravity, 10 times height. Now, the height we need to get is the difference between height 2 and height 1. So we're gonna subtract them. Height 2 minus height 1. So we'll get 48 centimeters, which while we're using this equation, we need to turn into meters. So 48 centimeter, to change it to meter, we divide by 100, which is gonna be 0.48. So if we do this on the calculator, it's gonna be 1.36 times 10 to the 4 times 10 times 0.48 is equal to 65280. And since they want kilopascals, we divide by 1000. So it is 65.2. Or if you want to round, it's going to be 65.3. And they are both accepted answers. 65.3. So that's it for this question. Next. James has a mass of 80 kilograms. If he stands on 1 foot and the area of his shoe is 200 centimeters squared, then the pressure exerted by his foot on the ground is. So here we're gonna use the same rule, which is pressure is equal to force over surface area, or area in general, but I like calling it surface area. So we're trying to find pressure is equal to force. How do we find force? Force exerted on the ground is gonna be weight. So we need to find the weight of James. And how do we find weight? What's the formula? W is equal to mg. So it's gonna be 80 times g, which is 10. So his weight is 800 over surface area, which is 200, times, as we said, centimeter squared to meter squared times 10 to the negative 4. So times 10 to the negative 4. And if we do this on the calculator, we will get 40000, which is equal to 4 times 10 to the power of 4. 1, 2, 3, 4. So yeah, that's it for this question. Question 20 now. A crush depth is the maximum depth a submarine can submerge without getting damaged. The crush depth of a Seawolf class submarine is about 730 meters. use density of salt water 1020 kilograms per meter cubed, and G is equal to 10. So we need to find pressure. We already know our formula is equal to density times gravity times height. So we know density. We're going to substitute the values. Pressure is equal to density, which is 1020, times gravity, which they told us is 10, times height, which is 730. If we do this on the calculator, we will get 7446000. Since they want million Pascal, so we need to divide by a million, which is 6 places. So on the calculator, we'll divide by a million, and we will get 7.446, which is 7.44, or if you want to round, 7.45, and they are both accepted answers. Question 20, question 21. This is also memorization. How a plunger works. Sticks to the surface of the floor under the influence of atmospheric pressure, basically, since the pressure outside the sucker is greater than that inside of it. So this is memorization. When a vacuumized tube A of radius 1 centimeter is placed into a bucket of mercury, the liquid rises in the tube to a height of 800 millimeters. If another vacuumized tube B of radius 2 centimeters is placed into the same bucket of mercury, the liquid will rise in this tube the height of. So here you just need to understand that since they're in the same liquid, the liquid is gonna rise to the same point. That's it. Since they're both dipped into mercury, then the height of liquid reached in A is also gonna reach in B. It's gonna be the same. So 800, 800. That's it. Question 23. Okay, question 23 is also memorization. You need to memorize that this is a barometer, and it measures atmospheric pressure, and its unit is millimeter per mercury. So this is just memorization. Question 24. Okay, so we're gonna do the same thing we did in the previous question, in one of the previous questions, which is we're gonna use the rule, uh, uh, which is pressure. Okay, stop right there. Pressure is equal to density times gravity times height. Okay, so we already have pressure, and we have gravity, and we have density. So, and they gave us height 1. So we need to find height 2. So what we're gonna do here is pressure, which is 30 kilopascals, so 30,000 is equal to, we need to change the density from gram per centimeter cube to kilogram per meter cubed, which is what we've been doing. We need to change it into that unit. So you need to memorize that from gram per centimeter cubed to kilogram per meter cubed. You multiply by 1,000. Okay, so we're gonna do that. So now we have pressure is equal to 30,000 is equal to density. So it's gonna be 13.6 times 1,000, which is 13620, times gravity, which is 10, times height. Now, as we did in the previous question, the height is supposed to be height 2 minus height 1. But we only have height 1, we don't have height 2. So we're going to substitute height 2, which we don't know, by x, minus height 1, which is 15. But since it's 15 centimeters, we need to change it to meters. So 15 divided by 100, which is going to be equal to 0.15. So x minus 0.15. So now if we write this on the calculator, 30,000 is equal to 13,600 times 10 times bracket x minus 0.15. And if we solve for x, we'll get that x is equal to 0.37, which is in meters. Since we made 0.15 in meters, it means that what we're going to get is in meters. And they want it in centimeters. So to change it back, we multiply by 100. So we'll get that height 2 is equal to 37 centimeters. And that's our answer. So yeah, that's it for this question. Next. What happens to the potential energy? Okay. The diagram below shows how the temperature of water vapor changes as it cools. So this is basically the same as one of the previous multiple choice questions. We just need to know what happened to potential and kinetic energy. So what happens to potential energy of the molecules of the sample in the time interval 0 minute, 1 minute? So this is 0 and this is 1. So basically this. As we said before, the potential energy only increases or decreases during the vaporization or during this phase, which is the straight line. It could be vaporization or condensation or whatever. So in this phase, potential energy increases. But here in the question, they asked about the potential energy in this interval, this time interval. So in this time interval, potential energy stays the same, while kinetic energy is the one increasing. So that's it for this question. Now, part B. Okay, now, part B. What happens to the potential energy of the molecules of the sample during time interval 10 minutes, 15 minutes? So, 10 minutes, 15 minutes. So it's here and here. They're asking what happens to the potential energy. Now, as we said, on this line, potential energy is going to be changing. Now, here, since the temperature is being decreased from 120 till it ends up at 85, this means, and they also told us that temperature of water vapor as it cools. So basically, they are cooling water vapor, which is a gas, to change it into a liquid, which means that on this line, if it was the other way around, so if it was at the bottom, then increased, then stayed, then increased again, then potential energy would be increasing since it would be gaining potential energy since it is transformed into a gas. But here, our 1 second. Okay. So if it started at the bottom, then went up, then stayed straight, then went up again, potential energy would be increasing since it is going from a liquid to a gas. But here, since it is going down from a gas to a liquid, then our potential energy is decreasing, which is why our answer to what is happening in between 10 and 15, this part, potential energy, is decreasing. So that's it for part B. What happens to the average kinetic energy of the molecules of the sample in the time interval 20 minutes to 22 minutes? So 20 minutes to 22 minutes. So basically it's going down. So since temperature is going down and we are not on the straight line anymore, it means that the kinetic energy is also going down. While if it was going up, if temperature was increasing, for example, in this case, then kinetic energy would also be increasing. So that's it for part C of this question. On to the next one. The kinetic energy of random molecular motion in the body is called heat energy. This is just memorization. The temperature of gas is 1000 Kelvin. The average speed of its particles is 600 meters per second. Okay, so for this question, we're gonna write a ratio as well, which, okay, so we're gonna write a ratio which is V2 over V1 is equal to radical T2 over T1. So we're trying to find V2, which is the second speed of the gas, sorry, what it will become. So let's substitute our values. V2 over V1, which they told us is 600, is equal to radical of T2, which is 250, over T1, which is the original temperature, 1000. So we're gonna do this on the calculator. This part, we're gonna get radical 250 over 1000 is equal to 0.5. So we'll have V2 over 600 is equal to 0.5. So we just multiply this. V2 is equal to 300. And that's our answer. So yeah, that's it for this question. Now question 28. Okay. Now, a diver produces a bubble of air volume 2 milliliters, 5 meters below the surface of a river. Assume the temperature of the water is the same at all depths. Take G is equal to 10 meters per second squared. Atmospheric pressure is equal to 100 kilopascals. Density of the water is equal to 1000 kilograms per meter cubed. Now, to solve this question, we're gonna just use we're gonna use the same rule, which is P is equal to density times gravity times height. So we're trying to find pressure for part A, pressure on the walls of the bubble. So pressure is equal to density, which they told us is 1000, times gravity, which they told us is 10, times height, which they told us is 5. So if we do this on the calculator, we'll get 1000 times 10 times 5 is equal to 50,000. Now here, since they asked us for kilopascal, we need to divide by 1000. So we'll get our answer is gonna be 50 kilopascal. Now, since they told us that it's below the surface of a river, it means that this is the liquid, the bubble is here, and above the liquid there is also gas, which is the atmosphere. So they also told us that atmospheric pressure is 100 kilopascal. So to our original pressure, which is by the water, we're gonna add the atmospheric pressure. So it's gonna be 50 kilopascal plus 100 kilopascal, which is given in the question. So our answer is gonna be 150 kilopascal, which is the correct answer. Now for part B, we're gonna use the rule, which is P1 V1 is equal to P2 V2. Okay, so of course it's over N1 T1 N1 T1, but since it's the same bubble, so there's no change in mass, and they told us temperature of the water is the same, so same temperature, so it cancels out. So we will end up with P1 V1 is equal to P2 V2. So we need to get P1, which we already got here. So it's going to be 150 kilopascals times volume, which we got, they told us here, the air bubble of volume 2 milliliters. So 2 is equal to P2, which we need to think here a bit. So they told us the volume of the bubble as it is about to surface the river. So this is the river. Before, when we calculated that the pressure is 150, the bubble was here. Now they told us it is about to surface very very, so it is right here, which means that the pressure above it is only the atmospheric pressure, which is, they told us, is 100. So we're gonna write P2, which is the second pressure, is equal to 100 kilopascal. Since it is about to surface, there is only air above it. There is no more water. So pressure 2 is gonna be atmospheric pressure times the new volume. Now if we do this on the calculator, 150,000 times 2 divided by 100,000, we'll get 3. So we'll get V2 is equal to 3, which is our answer here. And yeah, that's it for this question. Now 29. Okay, so we're gonna use PV is equal to nRT. A whipped cream chart is a metal cylinder filled with N2O gas. The interior volume of the charger is 10 centimeter cubed and it contains 0.18 moles of N2O, nitrogen, dinitrogen oxide. Use R is equal to 8.3. So we're gonna use this rule. We're trying to find pressure. So pressure times, we need to do volume. Now, centimeter cubed, we need to make it meter cubed. So you need to memorize from centimeter cubed to meter cubed is times 10 to the negative 6. So you need to memorize from centimeter cubed to meter cubed is times 10 to the negative 6. From centimeter squared to meter squared is times 10 to the negative 4. Okay? So here we have the volume in centimeter cubed. We need to make it meter cubed. So we have pressure times 10 times 10 to the negative 6, which is to make it meter cubed, is equal to N, which is the number of moles. They already told us is 0.18, times R, which is, they told us is 8.3, times temperature, which is also given 300. So if we do this on the calculator, we have to divide by this on both sides. So we have to take this here as well. So it's going to be 0.18 times 8.3 times 300 divided by 10 times 10 to the negative 6. If we do that on the calculator, we'll get 4482000, which is okay, let's erase this now. Okay, now we got this answer. Since they said they want it in million Pascal, we need to divide by a million. So 1, 2, 3, 4, 5, 6. We'll get 44.8, which is our answer. Yeah, that's it for this question. Question 30. A fixed amount of gas is initially at pressure P, volume V, and temperature T. If due to certain processes the pressure of the gas is doubled and the volume has tripled, what will the new temperature of the gas be? So here we're gonna do it theoretically. So PV is equal to nRT. We're gonna write our same thing. So pressure of the gas is doubled, so it's 2P, and volume has tripled, so 3V. So in total, we multiplied this side of the equation by 6, right? So it's going to be 6 PV is equal to, we also need to multiply this side of the equation by 6. But then since they told us it's a fixed amount of gas, so we can't multiply the moles. It's going to be the same number of moles. And R is a constant. It's a gas constant, so we can't change it. So the only thing we have left to multiply is T. So it's going to be 60. So what will be the new temperature of the gas be? 60, which is what we just found. That's it for this quiz. I hope you guys understood. Sorry if I made a few mistakes or took a while, but it's Ramadan and we're all tired. So yeah, if you have any questions, please don't hesitate to reach out to me. And thank you. Good luck in your exams. Bye bye.